All right, and now we have the last presentation for this session, which is titled 5G Wireless Communication for Autonomous Excavation. I don't know if the presenters are online or in the room.
The presenters are on site.
Perfect.
Okay, thank you, Chairman, and good afternoon. I'm Rauno Heikkila, and together with my colleague Tanja Kolli, sitting here, we came to introduce our research carried out in Oulu, Finland. 5G wireless communication for autonomous excavation. That's like the first time we had touch with 5G. There's a large Nokia company's research center in Oulu, and we have nowadays finally started cooperate with them, learning that 5G offers a lot of great possibilities for information communication, like massive machine-to-machine communications and connecting billions of devices without human intervention and so on, and ultra reliable low latency communication and so on. And like we were very excited to start that experiments together. Our tool and machine with which we tested 5G network was our smart excavator case, 8 tons bobcat excavator. We have developed different automation control methods to that and are able to drive that with human guidance principle remotely or teaching. We can teach the machine to do something with a human operator and then automatically repeat that. Then we are able to generate the tracks from BIM models and drive that totally without human operators. There are some examples of teaching, so bigger video is a teaching period and the smaller video is repeating that. And one researcher sitting there in the cabin to look at that. We have started to utilize this automation in our special educational workshops, and also our students are every year gathering to Oulu Zone Test Center to practice those things. That model-based autonomous control is the most interesting ones. One of the still, I would say, we do not have very much adaptive features yet in the machine. We can drive that automatically and utilizing the BIM model information, and that's way. Next, we are going to implement some specific adaptive toolbox developed in the car industry so far. That will be quite interesting. Then next experimental time. We did 1 year ago the first 5G test with our autonomous excavator in our campus, where Nokia company has set a 5G test network working 2.3 gigabytes per second frequency and offering that kind of possibilities to test different downlink or uplink information transferring. Downlink means that from internet we can upload videos and materials and utilize them in a moving machine, and uplink means that if we have equipped a machine with lots of sensors and video cameras and laser scanners, then we could then upload them to some remote control center. And we learned that uplink direction in 5G network is very limited if we compare to downlink direction. And that was something interesting. We equipped the machine with the omnidirectional antenna, which offers the same capacity to each of the directions from the top of the machine and use that test network located at our university campus. The base stations were on the top of the buildings around the machine, and that was a quite open parking area. We drive that machine and everything should have working very well. There's some exams. We were not able to cut the ground base driving on the asphalt layer and thus testing the different autonomous movements and like comparing the information transferring between 4G and 5G networks. That was the key idea, and then some, is this working or not, like movements of that. And that last one video includes also some break of that autonomous operation. Due to some reason, we are thinking that the reason was that the machine was rotating and the booms of the machine were also rotating and turning, and that affects made some effects on the radio signals between the base stations and the antenna and the machine, and that totally broke down the operation in autonomous mode. We were measuring that information communication with a specific software system by one Finnish company, Kaitotech. COSIM system includes some like measurement units. We were able to set to different parts of this total system and real-time measure the information transferring and show that in the one drive or after 2 minutes and 16 seconds, the signal strength dropped down, and at the same time, the autonomous operation was also broke down. So there are lots of more detailed information in our paper. If you are interested, you can read that. But we also compared it to 4G and 5G capacities and did not see any remarkable improvements in 5G network. That was like one interesting. And these are like a very limited downlink, uplink direction is important, because if we are going to develop forward autonomous operation with plenty of machinery, and all of the machinery would include a lot of sensors and providing huge amount of real-time data, that is not possible in 5G network due to limited capacity to that direction. Nokia has said that that is one which can be changed in a private network applications if you have certain closed area like in underground mine. Sandvik company has installed that kind of. A little bit they have been able to improve that uplink capacity, but in open networks that is not possible due to some synchronization problems in information communication. And that was like the first test we have right now in Finland. There's a summer vacation time, but we already started the preparation for the next 5G test. That's also going to bring that machine to underground mine and test that in that private network solution with better uplink capacity. And our next feature, we are right now starting the autonomous machines farm research project with interesting technology companies in Finland and aiming to also utilize that in real-time information communication between different types of machinery, and we are not going to utilize 5G network in that kind of operation. So that was my presentation. Thank you.
Thank you so much. Do we have questions from the audience?
So one question here.
So if you can just clarify, so you have a remote operator that provides waypoints and the machine just does MPC between the waypoints, or how does the system work? Like, where is the 5G link being used?
So in remote control operation, everything worked very well. we had a remote control like that kind of cabin where the human operator was sitting and nearby around 100 meters from the machine in that experiments.
Cool.
Yeah. Thank you for your attention.
Thank you so much. Actually, if I can ask one last question, I was curious, how did the industry and university collaboration started? If you can share a bit of details of that, as maybe could be useful. I know, for instance, us at Stanford, we haven't had any kind of real like machine experiments on campus, and how did that go about?
Yes, that's a very good point. And question. So in Finland, the research funding comes from a Business Finland organization, and the funding instrument is joint research project with the key technological companies which are developing export. And that's way that has forced us to cooperate all the time with the technology companies in Finland, with the contractor as well. So that is like we have met that to be very useful and cooperated strongly with the companies.
Thank you.
Thank you.
I'd like to thank all the presenters for today. I certainly learned a lot, so I hope you all in the audience enjoyed it as much as I do. Really wish I could have been in person today, and I think up next in the agenda is lunch for everyone. And yeah, looking forward to also connecting with you in the afternoon. There are a few more sessions on also construction management and some and application sessions. So yeah, enjoy the rest of the day, and thank you all.
Thank you, Professor Brosk. And so I think that we can now close the session and go to have lunch. Thank you.